So I'm going to ask you to start writing down some of these. These are the factors that influence climate. So here are the first two that I'd like for you to get into. Sunlight and latitudes are the first two. So this should all look a little bit familiar to you because we talked about this in the space unit, right? It's the uneven heating of the Earth. So because the Earth is tilted, it does not get the same amount of sunlight. You see how the most amount of the sunlight, look how thick this yellow arrow is right here at the equator. The total amount, the highest solar energy input is at the equator right over here. And then that amount gets spread out over a wider distance over here in the northeast and the southeast areas right over here. Even less over here in this areas where they're calling it the westerlies in this particular area. And then barely any to the ice caps. And in fact, they can go for months at a time without seeing any sunlight at all. So that's why it tends to be coldest up here climates, and then warmest climates right over here. And then there's seasonal climates, right? Depending on if it's tilted away or towards it, it's going to get more of that direct sunlight. And it's all about the latitude that you're located at that depends that. And it depends on that. And then when you look over on the right side over here, you see these patterns of this cycling air right over here. So notice how this is a tropical rainforest here. And the warm air rises up over here where it cools down compared to there and it sinks back down. So these are called convection currents. And you can see how as it cools down, sinks down over here and then rises up over here, these areas tend to be drier. So you're going to have these drier cactus-like areas in these two pockets over there. So it's going to be very dry and it's going to be very wet over here and a little bit wetter over in these areas with more weather as well. So the Earth's rotation has to do with day and night, but it's the tilt that talks about how much direct amount that it gets, direct sunlight, and that has to do with heat. So if you can look over here at the equator, you could see how, remember, this warm air rises because it's less dense, and then it's now going to sink back down, but it actually travels downward more closer to the poles, and it's doing the same thing. It's sinking downward closer to where it's colder at the poles. When it sinks down there, it heats up and it rises and it comes back down to the equator, and these are called convection cells. And this is what drives the global winds, because as these global winds right over here are rising, they're trying to go towards the equator, the Earth spins. And as it spins, it causes this curve over here. You see how both of these are rushing down towards the equator, but then they wind up curving? And these cause these huge long-term global winds that are constantly curving in a certain direction. And they call this the Coriolis effect. So you can see over here, convection currents as it rises like this. So this wind is rushing upwards. This wind is rushing downwards. This wind is again rushing upwards because you have cold air rushing up towards where it's warmer, relatively speaking. And all of this has to do with the jet stream. And this image right over here is going to talk more about what the jet stream does. The jet stream is pretty interesting. It's always going in one direction. And it's this constant band moving all over the world. So the jet stream takes place in the stratosphere. And you probably have experienced a little bit of the jet stream before if you've ever gone on a plane and you flew across the country. So the jet stream is always going in one direction and is the direction that the Earth is spinning. So because the jet stream goes from west to east, that's why when you fly from, let's say, California to New Jersey, if you were to do that trip, you may notice that it's actually quicker to do that than it is to go the other way. Because if it's still called the jet stream because that's like the area in the sky where planes can fly. So it's like giving you an extra boost, pushing you along, and you actually save almost an hour's worth of fuel that they calculate roughly. Whereas if you're flying the other way, you have to avoid the jet stream or go against the jet stream, and that's going to slow you down. So of course, we're always looking for ways to save money, and this is one of the ways that they wind up save money by flying in the jet stream. If you look here on this convection GIF right over here, you can see that on this second layer right there over the United States. So you see how a big portion of the United States have those arrows moving upwards and to the right. Okay, so those are the global winds that are pushing upwards and to the right. Now, on northern Canada, you see it's coming more down towards the left, and you can see down by Mexico, it's also down and towards the left. So let's take a look at this. This is our wind map of the United States, and this is showing, I mean, this is like kind of current actually, about today at this time, and this is just like taking a whole bunch of models into effect right now, and you can kind of see the path that some of these different global winds are moving right over here. And you may notice a pattern if you kind of notice the direction that a lot of these are moving in. Do you see how it's all going, especially in this area, up and to the right? So that's because the winds that are originating down over here are pushing everything upwards that way. And you'd be saying, how come in this area it seems like it's moving a lot more downward? And that's probably because the winds that are here over Mexico are actually moving downward. So there's kind of nothing in this area that's pushing up as much. So it's just kind of interesting to see. And again, these are just what's happening today. It's not really reflecting, like, these could change. And the jet stream, which you've probably heard about already, is also probably moving up, like having something to do with the little barrier over here. So if you imagine an invisible stream of wind that's moving, kind of following my cursor here, you see how all of this is probably getting pushed upward like that. This guy here does a phenomenal job. It's a little bit of a longer video. You don't have to watch it if you don't want to, but if you're a little bit confused about how these global wind patterns work, I mean, this guy nails it. He really explains how this works in such a good way, and I can't do it better than he can. So I'm going to highly recommend that you go and check out his video there. Now, I am partial to this video here. I really like this one. This is showing something called aerosols. So aerosols are basically solids that exist in our atmosphere. So we have lots of different types of solids. So the blue is just representing, it's exaggerating the amount of sea salt that's in the air. So the blue is down over here, picked up from the oceans. Green is representing the carbon dioxide that is being released from forest fires. So of course that happens from areas where there's a lot of forests. The white is from fossil fuels and volcanoes. And then the orange red is just dust. So if we kind of try to pick up from so all this stuff is circulating in our atmosphere. And you can see over here that the dust starts mainly in the Sahara Desert right over here, but it's moving. It's being picked up by those global winds, and it's being transported all over the world. And a lot of it is making the journey over here. You might remember about the dust that gets settled down over here, and it helps kind of replenish the soil, the nutrients in the soil down here that helps support some of these rainforests, but it also comes to the United States. You can see all the fossil fuel is coming out of mostly of the most developed areas that have the most industries that are going on. So that's going to be in the United States. That's going to be in places like Europe and China, right? A lot of industry means that there's going to be a lot more pollution that's taking place. And of course, you can see over here the places with a lot of lush vegetation, so like Indonesia over here, Brazil, as well as here. That's the carbon dioxide that's being released. And of course, it says right here, the soot from fires in equatorial Africa. So right over here, there's an influx of the carbon dioxide because of the forest fires that are going on there. If this was more accurate, we would probably see a lot of this taking place from, or more up to date, I would say, from Australia because of all the wildfires that are going on there. Now it says, keep your eyes on Madagascar. The Karthala volcano erupted on January 12th. So Madagascar would be right down here. And you see this huge increase in white right over here. Now, whereas this would be unnatural man-made pollution that's coming out of China at a regular amount. There's not that much industry here in Madagascar, but that one natural eruption of all of that aerosol, like the solids that are getting released up into the air, comes from those big volcanic eruptions. So when we talk about how can clouds form, remember how clouds need that speck of dust or dirt for them to condense on? All of these types of things that are coming out, whether it's soot, ash, sea salt, chemicals in the air that are being released. All of that can happen from here. And it's showing, like, again, this is an exaggerated map here, but I thought this was really cool how they were able to do that.